Good day, students. In this clip, we're going to be reviewing how to convert from polar coordinates to rectangular coordinates. Okay, so let's write down the title of this lesson: converting between polar and rectangular coordinates. Okay. All right, we're going to start out by writing down the learning objective for this review lesson, and then we'll go over some examples. All right, so our learning objective is as follows. Learning objective. By completing 80% of the assigned classwork, um, you'll apply the conversion formulas in converting between rectangular and polar coordinates. Okay, so that's the learning objective for this lesson. All right, we're gonna start by going from rectangular to polar coordinates. So example one. Um, convert root 3 comma 3 into polar coordinates. Okay, convert this into polar coordinates. Now, first you want to ask yourself, what on earth is polar coordinates? And what is this? If we change it into polar coordinates, then this must be rectangular, which means this must be x and this must be y. So what are polar coordinates? Polar coordinates are r theta. So what we're doing in essence is we're going from xy, we're converting into r theta. So what do I need? I need r and I need theta. So what do the conversion formulas tell me? First one is r equals the square root of x squared plus y squared due to the Pythagoreans. And theta equals the inverse tangent of y over x, opposite over adjacent. We add 180 if x is negative, x is positive here, so we do not add 180. So let's apply this formula to these two coordinates. So r is going to be the square root of root 3 square plus 3 square. Okay? Now the square is square root. They cancel out in their inverse operations. You have 3 plus 3 squared is 9 equals the square root of 12. Can this be simplified? Let's see. Take out 2, 6, 2, 3. These two repeat, so they can break out of the radical. They can break out as just 1, right? They can just break out as 2. So 12 is basically 2 rad 3. Alright, so that's what r is. Now let's look for theta. Theta equals the inverse tan of y over x. Y is 3, and x is root 3. Okay? So let's use our calculators to figure this out. So fire up your calculators. Let's try out this inverse tangent. So this one always resets. The mode here always resets to radians, so I gotta make sure I'm in degrees first before I start. Okay, degrees. Alright, now we're looking for the inverse tangent of 3 over the square root of 3. Okay, so what is the inverse tangent of 3 over the square root of 3? Boom, 60 degrees. So theta is 60 degrees. So our rectangular form, our polar coordinate, is going to be our theta, which is 2 rad 3, comma 60 degrees. There goes your polar coordinate. Alright, now let's consider another example. Example 2. Convert -5, comma 2 pi over 3 into rectangular coordinate. Rectangular coordinate. Okay. Alright, write that down. Now, if we're converting to rectangular coordinate, what do we have and what do we need? Where are we going to and from where? Since this is rectangular, where we are going, that means this must be polar, right? This must be r and this must be theta. So in this problem, we're starting from r theta and we're transforming it into x, y. Okay? So we need the x and we need the y in order to write our rectangular coordinate. So using the formula we derived before, we know that the x is r cosine theta and y is r sine theta. Okay? So we just combine these values and input them here to compute what the respective coordinate values are. Okay, so for x is going to be -5 cosine 2 pi over 3. And then sine is -5 sine 2 pi over 3. Now if you look at the unit circle, 2 pi over 3, what are the coordinates of 2 pi over 3? If I think about my unit circle, 2 pi over 3 is 120 degrees, right? If I convert it, it's going to be 120 degrees, as this is 2 times 180 over 3. This comes out to 120. So I know 120 degrees reference angle is 60 degrees, so it's going to be in quadrant 2. So what are the coordinates for 60 degrees in quadrant 2? So you can just look at your unit circle. I don't have it right now, so I'm going to try and derive it. So if you go up 60 degrees there with the reference angle to 180, to 120, the x coordinate is going to be -1/2, and your y coordinate is going to be √3 over 2. So basically, the coordinate you're looking at is -1/2 and √3 over 2. So remember, the x coordinate is cosine and the y coordinate is sine for your unit circle. Okay, because you have one for the radii. So let's plug that in here. So for the x component, it's going to be -5 times the x coordinate of the 120 degrees in a unit circle, which is -1/2. If you work that out, that comes out to 5 over 2. Okay. And then for the y coordinate, it's going to be -5 times √3 over 2. It times it out, becomes -5 √3 over 2. So our rectangular coordinate is basically going to be 5 over 2, comma, -5 √3 over 2. Yeah, like that. Okay? Alright. Now, let's move on to equations. How about a little bit if we're dealing with equations? So, take a look at some examples now. Let's write the given equations. in polar form. Okay, in polar form. So if you're in polar form, remember all I have to see is, all I want to see is r and theta, no x, y, okay? So number 3. Number 3, what if I have x squared plus y squared equals 25? How do I do this one? I want to change this to just r and theta. Can I make a substitution here? Well, we know the formula that r is equal to what? The square root of x squared plus y squared. If r is equal to the square root of that, doesn't it follow that r squared is equal to x squared plus y squared from the Pythagorean theorem? Yes, it does, right? So x squared plus y squared can be simply replaced with r squared equals 25. Alright? And then to get r by itself, you square root both sides. And then you have r is equal to plus or minus 5. So you can say r equals 5 or r equals -5. This is the equation in polar form. Alright? Now let's try another example. What if we have a scenario, number 4, where we have x minus 3 squared plus y squared equals 9. And the task here is to convert this into polar form. Alright, so how do we do this one? First thing we want to do is, how about we expand this and see if we can set it up for easy substitution. So if I expand x minus 3 square, x minus 3 square, we can expand that one, right? It's basically x minus 3 times x minus 3, right? So let's do it. So x minus 3 times x minus 3 plus y squared equals 9. If I follow this out, I'm going to have x squared minus 3x minus 3x plus 9 plus y squared equals 9. Now, how about we put the squares together? Okay, I'm going to put x squared plus y squared together. Put the squares together. And then these two I can combine. I can combine these two to give me -6. Combine this and this to give me -6. -6x. And this 9 right here is a number. How about I move it over to the right side? So I'll move it over to the right side, subtract 9 from both sides, and that will give me equals 0. Okay? Alright, now, what can I do here? I now can start making my substitution. I know that r squared is equal to what? X squared plus y squared. We just talked about this in the previous problem. And I also know that r cosine theta is equal to x. So this first two terms will be replaced with r squared, and this x will be replaced with r cosine theta. Because in a rectangle in polar form, you cannot have x and y. Alright, so let's make the substitution. For this x squared and y squared, we're going to have r squared minus 6. Instead of x, we'll replace it with r cosine theta equals 0. Alright? Now, what goes into r squared, 6r cosine theta, and 0? We know everything goes into 0, right? Because 0 times anything is 0. So we can divide every single term by r. Okay? So divide this by r, divide that by r, and divide this by r. So that gives you r minus 6 cosine theta equals 0. And anytime you want to write this in polar form, if possible, get r by itself. Can I get r by itself here? Yeah, that's the standard way of writing it. So to get r by itself, I'll simply add 6 cosine theta to both sides, and that will accomplish the goal for me, okay? So at the end of the day, I will have r equals 6 cosine theta. Okay? End of story. Alright, let's try another example, and then we'll move on to writing equations in rectangular form. Number 5. Number 5, what if we have the situation y equals 3? How do we do this? Well, to do this one, we know that y, we know the formula that y equals what? R sine theta, right? So I'm going to replace this y with r sine theta. So this becomes r sine theta equals 3. So I stated earlier that r should be isolated, so we need to get rid of this sine theta. So what I'll do is divide both sides by sine theta. So divide the first side by sine theta, and divide the second one by sine theta. So that's going to give us r equals 3 over sine theta. Got it? Now, if I reciprocate sine, what does that give me? I get me r equals 3 cosecant theta. Because remember, the identity we studied before, 1 over sine theta equals cosecant theta. Cosecant is the reciprocal identity of sine. Okay? So that's that. Alright. Let's try one last example. Convert, number 6, convert the given equation into rectangular form. Okay. What if we have this equation r equals 5 cosine theta? So how do we do this one? Well, I know that r square, I know what r square can be or what r is, but this one needs an r because if I have r cosine theta, that is automatically an x. So how can I make this r cosine theta? I need to multiply this side by what? By r, okay? Whatever I do to this side, I have to do to this side. So I times this side by r, and times that side by r, so that I can have a substitutable component on the right side. So we're going to have r squared equals 5r cosine theta. Now check this out. R squared, we know that r squared is equal to x squared plus y squared. Right? So we're going to have x squared plus y squared. 5, you see this r cosine theta here is just x. So you have x right there. And guess what? That is the final answer. Alright? Thank you for paying attention to this presentation. Remember, it's uploaded on YouTube for your viewing pleasure. Now we're going to go ahead and start with the password.